Today we're going to be learning about mean, median, mode, and range. Mean, median, mode, range. These are four things that you're going to want to be able to calculate for any set of data you're given. So sometimes our set of data is just a group of numbers that they've already given to us, as we're going to see in our examples today. Sometimes our data can come off of a chart or a graph or a line plot or a stem and leaf plot. But no matter what your given set of data is, you're going to want to be able to calculate mean, median, mode, and range. Oftentimes I write it MMR. Now, the M's are kind of set apart from the range because all of the M words, mean, median, and mode, are what people call measures of center or measures of central tendency. So they all give us a number that falls somewhere in your data, within your data. So we're going to work on learning how to calculate each of those today. First up is going to be mode. Mode is probably the easiest one to calculate, and the mode often gets nicknamed the Momo because the mode occurs the most often. It's also kind of known as the favorite of our data. The first thing that you're going to want to do, no matter which one of these you're trying to calculate, is you're always going to line your data up from least to greatest. That is a very, very, very important step. Not so much for the mode, but especially for some other ones of these that we're going to be calculating. But we just want to get in the habit of always lining our data up least to greatest, just like when we were going to put it into a line plot or a stem and leaf plot earlier. Now, if I want to know the mode, I'm looking for the number that occurs the most often, also known as the favorite number. So what number happens the most? The mode is the number that happens the most. Now, here's the interesting thing about mode. This is the only one out of the four we're going to learn that sometimes there is no mode. Or sometimes there can be a tie. And so this is the only one out of all four that this can happen. So let's take a look at our data. Our data is already lined up least to greatest. 1, 2, 3, 3, 3, 5, 9, 11, 13. Now for this set of data, we would look for the number that occurs the most. The number occurring the most here would be that chunk of 3's, which are very easily found when we line our data up least to greatest. There is no other number that occurs more often than the 3. So we would say that our mode is 3 for this data. Now, had there been, let's just say that our data was 1, 1, 1, 2, 3, 3, 3, 5, 9, 11, 13. If there had been 3 1s, then we would say our mode is a tie. There would be 3 and 1 for our mode. But since this data did not have all those extra 1s, then we're just going to stick with one mode, 3. Now, what if this data didn't have all those 3's at all? Maybe these 3's weren't there. What if our data was just 1, 2, 3, 5, 9, 11, 13? In that case, we would say that there is no mode because no number occurs more often than other numbers. So I'm just going to go back to the data that we were given, circle those 3's so I know that that is our mode because it occurs the most often. All right, the next thing we're going to learn how to calculate is the median. And the median sounds a lot like medium. So if you think about the median is the number that is in the middle, the exact middle of our data. Of course, that only works if our data is lined up from least to greatest. So we would line our data up least to greatest and find the number directly in the middle. Now there's a neat way to kind of find this on your thinking paper as you line your numbers up. You're going to cross out one number on each side until you end up in the middle. Median's the middle, just like the median of the road is the grassy part in the middle of the road. So first, let's make sure our data is lined up least to greatest. 1, 2, 3, 5, 7, 9, 11. Looks good. So we're going to cross one out here and one out here. You always have to have a partner on the other side if you're crossing things out. Partner, 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 partner. You are in the middle now because you have 3 crossed out on this side, 3 crossed out on this side. That means the median of this data equals 5. Now this works out really nicely when you have an odd amount of numbers, because there's always going to be one oddball number left in the middle. It is a little trickier if you have an even amount of numbers. So let's take a look at the next example. First, we're making sure we're lined up least to greatest. 2, 2, 6, 7, 9, 10. And we go to cross out our partners. There's a set. There's a set. Now we're stuck with 6 and 7 in the middle. And unlike the mode, there cannot be two medians. So we do actually have to find the number that would be found directly in the center of 6 and 7. Now you could think of a number line and think, well, what would fall directly in the middle of 6 and 7? And some of you have good enough number sense that you'd be able to figure out that 6 decimal 5, 6 and a half, 6 and 5/10 would be that center number. Now there is a mathematical way to figure that out. If you're stuck with 2 in the very center, you can always take your calculator and you can add together the two numbers, and then you can divide by 2. So what that would look like is, in your calculator, you would take 6 plus 7 and get 13, and then you would want to divide by 2, so that we're finding exactly what is in the center of those numbers, and that would also give you 6.5. So that's when median can be a little tricky when you have even numbers, because you could have to get stuck with 2 and figure out what to do. But you have two strategies. 1, think of a number line. 2, use the calculator, add them together, divide by 2. Alright, next up is going to be finding the mean of a set of numbers. Mean, some 5th graders remember the mean because it is mean, they say. The mean is the average of our data, or the fair share. So a lot of 5th graders remember it's mean because it is the most work. So first we're going to make sure our data is lined up from least to greatest. And then we're going to take our data, and instead of some people, let's just think of this data as the amount of candy you have at your house. Instead of one person having 1 piece of candy and somebody else having 11 pieces of candy, the mean means that we're going to take all of this data, we're going to put it together. So we're going to actually add up all of our data and put it into one big pile. So if this represented pieces of candy, we would take all of our candy, pile it together in one big pile, and instead of that one person only having 1 piece and someone else having 11 pieces, we would then divide the candy up into equal groups. So that way everyone got their fair share. And it wasn't that one kid with 11 pieces and somebody else only having 1. Everyone would get a fair share. This is also how your grades work. We talk all the time about your average in a certain subject, or what your grade is on your report card. Well, what your teachers do is we give you the fair share of your points. So if you scored, let's just say, a 30, yikes, on one quiz, but then you got a bunch of hundreds later on, okay, maybe you threw a B in there too, maybe an 85. If this was your data for, let's just say, science, it would not be fair for us to say, okay, well, they did get a 30F, we're going to give them that on their report card. That wouldn't work. Or it wouldn't really be fair to say, oh, they get 100 on their report card, because you did have some lower grades. So what your teachers do with all those grades is we find the mean, the average, or the fair share, all meaning the same thing. We find the fair share, and we would add up all your grades, and then we would divide, and here's where the tricky part comes in. You have to divide by the number of pieces of data you have. So what you divide by for this really depends on however many numbers you have. So if I was doing that for your grade up here, there would be 4 numbers. So I would be making 4 equal piles. I'd add all these grades up, and then I would divide by 4, because there's 4 different grades, 4 different assignments. Now for our example down here, we're going to add up all our numbers. And by the way, this is a calculator skill, so you are absolutely allowed and expected to use a calculator for all of this. But you would just add up all of your data. So 1 plus 2 plus 3 plus 3 plus 4 plus 9 plus 11. And that would give you 33. And then you have to divide by the number of pieces of data you have. So for this set of data, I have 1, 2, 3, 4, 5, 6, 7 numbers. So I'm going to divide by 7 for this set of data. So 33 divided by 7. And it's going to give me this really long number, but I'm just going to take the money amount. So I'm going to stop at the hundredths place, 4.71. So that means that the fair share, or the mean, for this set of data is 4.71. So if we did put this in the context of candy, instead of that one kid having one piece of candy and someone else having 11, we would put everyone's candy together by adding them all up, and then we would divide it into 7 equal groups, and everyone would get 4.71 pieces of candy. And that is how you find the mean. So if you ever are trying to remember how to calculate the mean, it may help to remember that the mean has 2 steps, whereas most of these others that we're learning just have one major thing to do. The mean, you have to do 2 things. Add them all up and then divide by how many pieces of data there are. The last thing that we're going to be learning how to calculate is the range. The range is also called the variation or the spread of our data. So how much our data spreads or ranges or changes from the smallest to the biggest. It's called the range, the variation, or the spread, or how much our data spreads. So first, of course, we're going to line up our data from least to greatest. So that way we can see how much our data ranges or varies or spreads. And we want to know what is the least number in our data. We also want to know what is the greatest number in our data. And then we're just going to subtract. Of course, we're going to put the greatest number in front so that we end up with a positive answer, not a negative answer. So we're going to take our least number and our greatest number. So if I look at this set of data, I'm making sure it's lined up least to greatest. 1, 2, 3, 3, 3, 5, 9, 11. I want my lowest number and my highest number to find the range. So I'm going to take 11 minus 1. I'm always starting with the greatest number because that's what we do when we subtract. 11 minus 1 will give me 10. And that makes 10 our range. The largest number minus the smallest number. And that is how we find the range of our data. So I hope this has given you a good introduction, and I know it's a lot of information at once, so there is going to be another video coming up very shortly of how to actually practice some more with mode, median, mean, and range.